Welcome to the Pre-Calculus Mathematics for Calculus textbook series. This lesson is written based on Chapter 1, Chapter 1, Section 6, which I've broken into 4 parts. This is the second part, Section 6b, Arithmetic Operations on Complex Numbers. Today's lesson, as I mentioned, we're going to learn how to add, subtract, multiply, and divide complex numbers. Before you start the lesson, you should know how to do the same thing with algebraic expressions. Multiplying binomials, etc. You're also going to learn about our buddy, the complex conjugate. Let's get started. Pause the video and simplify the following expressions and restart when you are ready. 3, 2, 1, now. Okay, how did you do? If you struggled with this, Chapter 1, Section 3 is a great place to start. Okay. Adding and subtracting complex numbers is a lot like adding and subtracting like terms. You combine their real parts and their imaginary parts separately. Officially, we can say that the sum of a plus bi and c plus di is a plus c, real part, plus b plus di, imaginary part. For the difference of complex numbers, we can say that a plus b I should say minus c plus di is a minus c, real part, plus b minus d, imaginary part, I. Give these a try. I think you'll be able to do them on your own. I'm going to start the solution now. So for part A, we're going to gather our real parts together, 3 plus 4, and our imaginary parts together, 5 minus 2i. That gives us 7 plus 3i, which is our final answer. For part B, I'm going to distribute the negative sign first just to make sure my math stays tight. And then I'm going to do the same thing, 3 minus 4, and then 5 plus 2i to get negative 1 plus 7i. And we're moving. Multiplying complex numbers is a lot like multiplying algebraic expressions. We FOIL as usual. So for example, if a plus bi and c plus di are two complex numbers, they're written in standard form, their product is defined as follows. You FOIL to get ac plus adi plus bci plus bdi squared. But remember that I squared is actually negative 1. We recombine and we get ac minus bd plus ad plus bci. Okay, so we need to express the following in the form a plus bi. All that means is we need to split our real and imaginary parts once we get everything figured out. So first I'm just going to FOIL as usual. 3 times 4 plus 3 times negative 2i plus 5i times 4 plus 5i times negative 2i. Then I'm going to simplify to get 12 minus 6i plus 20i minus 10i squared. Now I have to remember that I squared is negative 1. I substitute for that, recombine my like terms, and I get 22 plus 14i. Powers of imaginary numbers have a really interesting cycle that makes the calculation with them kind of cool. Let's look at the first few powers of I. Like all numbers, I to the 0th power equals 1. I to the 1st power equals I squared is negative 1 as defined. I to the 3rd is going to be I squared times I, which is negative 1 times I, which gives us negative I. Let's keep going. I to the 4th is I squared squared, which is negative 1 squared, positive 1. I to the 5th is I to the 4th times I, 1 times I, which equals I. And I to the 6th is I to the 5th times I, which is I times I, which gives us negative 1. I don't know if you can see a pattern, and that bracket was supposed to show up a bit later, but basically I'm seeing cycles of 4. 1, I, negative 1, and negative I. So why does that help us? So to determine the value of a power of I, we can simply divide the power of 4 and use the remainder as our new power. Let's do an example together. So I to the 23rd. Okay, so the first thing I'm going to do is I'm going to divide 23 by 4, which gives me 5 remainder 3. That remainder becomes my new power. And I to the 3rd, as we now know, is negative I, and that's it. Let's talk about the complex conjugate. Two complex numbers that have identical real parts but imaginary parts that are opposites are called complex conjugates. For example, a plus bi and a minus bi are conjugates, and we use the notation z and z bar. So your conjugate is going to have a bar over it. Now, if we multiply them by each other, we get a very helpful result. Okay, our result is a squared plus b squared, which is a real non-negative number. That's going to help us with dividing complex numbers. So let's figure out the complex conjugate of each of these numbers. I'll give you a second before I press go. Ready now. Okay, how did this go? Remember, we're only changing the imaginary part. So if you look at numbers 3 and 4, 4i becomes negative 4i, changing our imaginary part. 5 stays the same because it doesn't have an imaginary part. So we need the complex conjugate to divide complex numbers. To simplify the quotient a plus bi over c plus di, we multiply the numerator and the denominator by the conjugate of the denominator, and then we simplify as usual. Oops. I need to simplify 3 plus 5i over I minus 2i. So the first thing I'm going to do is multiply by the complex conjugate in my numerator and my denominator. My complex conjugate is 1 plus 2i. Remember, change the sign of your imaginary piece. Okay, and now I just have some math to do. I'm going to simplify. Remember, I squared is negative 1, and I get to 11i minus 7 over 5. Now, if we're asked to put it in the form a plus bi, we need to split our fractions, put our real part one place and our imaginary part another. So this becomes negative 7 over 5 plus 11/5 I. So in this example, I need to simplify 7 plus 3i over 4i. Okay, I do suggest that you pause the video, give this one a try. I'll start now. Okay, so I need my complex conjugate, which is negative 4i. I multiply my numerator and my denominator by that, and then I simplify. Substitute for I squared, always, and I get 12 minus 28i over 16. Now remember, we were asked to split this into a plus bi form, which means we need to split our fraction and reduce, which gives us 3/4 minus 7/4 I. Congratulations, you are a champion of arithmetic with complex numbers. Now, before we go, let's do a quick true-false statement check. The sum of two complex numbers is always a real number, true or false. Turn to your classmate and discuss.